The National Aeronautics and Space Administration is one of the most iconic agencies in the U.S. It has been responsible for many of American finer moments with its research and achievements. With one of the biggest budgets for any agency in the U.S., NASA is equipped to fund many high-power investigations. However, by teaming up with Elon Musk, NASA has unlocked many more opportunities. The latest example is the discovery on planet Neptune. What has Musk and NASA discovered on Neptune, and how does it affect you? Join us to explore Elon Musk and NASA's insane new discovery on Neptune that changes everything. What is the longest distance you have ever traveled? If you had moved from one continent to another, most probably in an aircraft, you could have covered thousands of miles. That is child's play compared with Voyager 2's journey. Moving in the opposite direction to its twin, the Voyager 1, the spacecraft reached planet Neptune in 1989, 12 years after it took off from Earth. It was, and still is, on a journey through the solar system. What it discovered on Neptune was mind-blowing. The spacecraft beamed the first images of the planet's rings, but there was another discovery. A massive and violent storm. NASA scientists were not expecting the storm Voyager 2 sent the pictures of. It was spotted in the southern hemisphere, appearing as a counterclockwise wind of up to 1,500 miles per hour or 2,414 kilometers per hour. It was the strongest ever recorded. Astronomers called it the Great Dark Spot. 5 years later, it had gone by the time the Hubble Space Telescope looked at the planet. This led to lots of questions about why the winds were so strong. The strong wind, however, was not the only thing puzzling scientists about Neptune. Its temperature was also a mystery. Voyager 2 revealed that Neptune is warmer than Uranus, despite being farther from the Sun. The conventional wisdom was that the farther you go from the Sun in the galaxy, the colder it became. Yet, Neptune had more heat than Uranus. The question is, where is the heat on Neptune coming from? As physicist Brian Cox discussed in his BBC documentary, The Planets, the source of this extra heat remains a mystery. However, the bigger puzzle was whether the two usual behaviors, that is, the strong wind and the elevated temperature, were in any way tied. Some scientists even speculated that unraveling one mystery would explain the other. But how would this be achieved? Measuring Neptune's temperature, however, is not so straightforward. For example, on Earth, you can take measurements on the solid surface and calculate the global average. That is not possible on Mars, which is made up of gases. So if you must take a temperature of Neptune, it has to be at an altitude. This is where you need to make another decision. At what altitude will you take the measurement? There is something else about the temperature measurement taken by the Voyager 2. Obviously, it took the temperature from the outermost layer. At that point, the temperature of Neptune is not so much higher than that of Uranus. But since Neptune receives less solar illumination because it's farther from the Sun, this shouldn't be the case. What this similarity in temperature suggests is that Neptune is warmer in terms of how much heat it emits in comparison to the amount of heat it absorbs from the Sun. According to Anthony Del Genio of the NASA Goddard Institute for Space Studies, Voyager's measurements show Neptune emits more than twice as much heat as it absorbs from the Sun, while Uranus does not. This doesn't make Neptune unusual, though. In fact, it makes Uranus weird because other planets like Jupiter and Saturn also emit more heat than they absorb from the Sun. As stated earlier, the progression of temperature as you go farther away from the Sun shows Jupiter to be the warmest of the gas giants, Saturn next, then Neptune. Uranus is the one that is out of place. Del Genio explained the oddity further, yet that unusual result is associated with the fact that Uranus does not have a significant internal heat source. In other words, Neptune is finding a way to warm itself up to the level of Uranus, while the latter is unable to generate any extra heat other than that gleaned from the Sun. But just what is an internal heat source? In simple terms, it is heat left over from the birth of the solar system when these planets were formed. The heat contracts out of the primitive solar nebula, forming an effect known as the Kelvin-Helmholtz contraction. The extra heat source on Neptune, Jupiter, and Saturn is primarily due to gravitational contraction. As the planet slowly gravitationally contracts, the material falling inward changes its potential energy into thermal energy, which is then released upwards out of the planet. For Uranus not to have such a heat source, something must have happened to it. So, the question is, why does Neptune produce heat internally, but Uranus